Last problem. The seating capacity of the Greensboro Coliseum is 22,000 people. Prior to an event, the rate of change of the number of people in the Coliseum is modeled by this, dCdt, where C is the number of people in the Coliseum and T is measured in minutes. Okay, logistically, like literally with the logistic function, this makes sense. So there's an event, and there's a few people that are in pretty early, and then people really start coming in all kind of, not all around the same time, but there's a higher rate of people entering at a certain point, and then you have a few latecomers, and then you can't get over 22,000 people in there. You're breaking fire code. So there is a seating capacity, carrying capacity. So it's number of people. It's not just population of things. It's number of people in an arena or something like that. It's a very practical application. So they said at a certain time there are 18,000 people in the Coliseum. Okay, that is the number of people in the Coliseum. C is the number of people in the Coliseum. So if you want to, you can start listing things you know. So C is 18,000 at a specific time. And it is increasing at a rate. So the rate of the number of people is changing at a rate of 150. Let me reword that. It was very clunky. The rate at which people are entering is 150 people per minute. And that's all we know. Write the differential equation. Okay, well, let's just start writing stuff and then filling things in, figuring out what we don't know. So, oh, here's what I do know. One more thing I do know. I do know the carrying capacity, which I will call L, is 22,000 right there. So let's start writing. We will write the formula. dCdt equals K times C, normally the population, or Y on the very front of the page, and then the carrying capacity minus the population. And so we'll just plug things in and find what we're looking for and see what we need, because they want us to write the differential equation, which means we need a couple things. We need L and we need K. And we know L, so clearly we're going to be finding K in this circumstance. 150 equals K times 18,000, and then 22,000 minus 18,000, and that gives me 4,000 times 18,000, and then we have 150 divided by that massiveness, and it gets ridiculous, so just bear with me. Here we go. 150 equals 18,000 times, that's 4,000. And that gives me ridiculousness, 72 million. And that is multiplied by K. So K is 150 divided by that last answer. And that helps me none. Ah, no. 150 divided by 72 million, you know what? 72 million is going to divide by 150. Ah, wonderful. It reduces to be 1 over 480,000. Okay, not done, because they did want us to write the differential equation that models the situation. So final answer is dCdt equals K, 480,000, and then C, just C. Now, why don't we put 18,000? Because that was at a specific moment. K is a constant. Carrying capacity is a constant. The number of people in the Coliseum, not a constant. Rate of change, not a constant. 22,000 minus C.